Good morning and welcome back from the Easter holidays. So this week, whilst you're doing your tracking tests in class, we'll be doing a little bit of differentiation recap and a couple of new differentiation skills. This first video is going to be very short. It's just a recap of the differentiation that you did earlier on in the year. Now, I'm not going to recap everything. I'm going to assume your knowledge of finding equations of tangents is solid. Finding your equations of normals is solid because those are the two things that we've done the most practice on. But I am going to focus in on two parts of differentiation. One, which is differentiation from first principles, and the second, which is to tell whether or not a function is increasing or decreasing across a limit, just because those are the bits I think are most likely to be forgotten. So the first one is that proving from first principles that the derivative of something is something else. And we're actually given a formula for the first principles differentiation in our formula book. And that formula is that f dash x is going to be f of x plus h minus f of x over h. So the reason that we do this is because this is linked to the gradient formula, which is y minus y divided by x minus x, and that can be derived from that. You can look back at our earlier video from the year in order to get that. So in our function, our f of x is 3x squared from the question, okay? And we also need to know what f of x plus h is. Now, f of x plus h is just basically taking, so if we look at f of x for a second, we take whatever's in the bracket, and that's what's being squared and then being multiplied by 3. So we apply that same rule, whatever's in the bracket is being squared and multiplied by 3. So we end up with 3x plus h squared. So now we're going to directly substitute those two things in. So we've got f dash x, which is going to be f of x plus h, i.e. 3 lots of x plus h squared, minus 3x squared, which is our f of x, and we're all going to divide by h. Now, one thing I've forgotten to put in, and you must never forget to put in, how terrible of me, is this is the limit as h tends to 0. Okay. Now, the reason that this is the limit as h tends to 0 is we're using this limiting function to find out as this difference in x tends towards 0, what is the gradient? Because we want to know the gradient at a specific point, not as the gradient of a chord between two different points. So this limit is immensely important, and I apologize for forgetting to put it in right at the beginning. You need to show it in every line of your working. So let's go ahead and expand this 3x plus h all squared. So we have limit as h tends to 0 of 3 lots of x squared plus 2xh plus h squared. That's the x plus h all squared, minus 3x squared over h. And then we're just going to expand and collect like terms. So we'll say f dash x is still the limit as h tends to 0. Expand this bracket. 3x squared plus 6xh plus 3h squared minus 3x squared over h. Now we're going to collect our like terms together and simplify that numerator down. So we can see that the 3x squared here subtracts this 3x squared, and so all we're left with is 6xh plus 3h squared divided by h. And then what we do, and we always do this bit, is we factorize that numerator by taking h out as a common factor. So we have h multiplied by 6x plus 3h divided by h. Keep going, lots of lines of work in here, but you're very handsomely rewarded for this in an exam. We're going to do h divided by h, which just cancels, effectively divided by h equals 1. So we end up with 6x plus 3h. Now is where we use this fact that h is tending towards 0, and we say as h tends towards 0, f dash x is going towards 6x. Therefore, f dash x equals 6x. So that's it. That's our differentiation from first principles, and it's always the same. All right. But what I recommend that you do is you write the formula f dash x equals, and then write down f of x, but then also to the side, write down f of x plus h. And make sure you get this f of x plus h right. That is absolutely the key part of this question. All right. How did we get the f of x plus h? Well, we look back at f of x. The thing in the bracket is being squared, then multiplied by 3. So the thing in the bracket, x plus h, is being squared and then multiplied by 3. And that then allows us to expand the bracket, collect like terms, and cancel. Okay, and this is always what you do. And you're good. So that's first principles, just a quick example for you to refer back to for this work that we're doing this morning. The second one is about a function which is increasing or decreasing, in this case, decreasing. So it says find the interval on which the function f dash x is decreasing. Now what we're talking about when a function is decreasing is the gradient of the function has to be less than 0, okay? And if you think about a function where its gradient is less than 0, for example, if I just take some random function like this, the gradient is less than 0 over here. So whatever this x value is, to the left of this, the function is decreasing. Okay, you can see it's moving down from left to right. And then from wherever this is, the function is also decreasing because it's moving down from left to right. So wherever the gradient, the steepness of the function is negative, you have a decreasing function, and conversely, an increasing function wherever the function is moving up from left to right. So if we're looking at the gradient being less than 0, we need to say, okay, f dash x has to be less than 0. So our first job is to find out what f dash x actually is. So we differentiate the function x cubed plus 3x squared minus 9x, and we differentiate it and we get 3x squared plus 6x minus 9. We know that we need to do this gradient function less than 0, so we're solving an inequality, 3x squared plus 6x minus 9 less than 0. Now we can simplify this down a little bit because we're effectively finding roots of a quadratic here and deciding whether to go left or right of them. Because this is less than 0, we can divide everything if possible to simplify our quadratic. So we can say this is x squared plus 2x minus 3, just dividing everything by 3. Then we'll check to see whether or not this can be factorized, and in fact it can be factorized. So we have two x's. We're going to have 3 and 1, 1's going to be minus, 1's going to be plus, so we can see that we've got plus 3 and minus 1, x squared plus 3x minus 1x, which is 2x, and then minus 3. So in order to decide which side of this, essentially, that we're working on, I'm going to draw a quick sketch of this little quadratic that I've created. Here's my x, and here's my y. So x plus 3x minus 1, the roots are going to be 1 and minus 3. This quadratic, if I did sketch it, would go through minus 3. So it's going to look, and forgive the sketch, a bit like that, right? A bit like that. So we're interested in where this function is less than 0, i.e. where does it exist below the x-axis? And I can see that this function exists below the x-axis for this entire period here, between minus 3 and 1. So the values that I'm interested in are x has got to be greater than minus 3, but also got to be less than 1. So the interval on which the function is decreasing, we describe in this way. So we say, therefore, the interval, and this is the way we describe intervals, we put them in a rectangular bracket with the lower limit first, comma, the upper limit. So it looks just like a coordinate, but using these rectangular brackets indicates that we're talking about a limit rather than a specific coordinate. So that's your quick recap. First principles and increasing or decreasing functions. Once you've done the questions on consolidation, in the next lesson, we'll have a look at differentiating some new stuff. But I hope the work goes well today. Let me know on Teams if you need any help. All right. Many thanks, everybody. Take care.